Very good morning, all of you, dear students. Uh, Very good morning to also those who are wishing me in the chat section. This is our second class of basic principles of organic chemistry. So, in the first class, we discussed some introductory aspects like how to identify the hybridized state of carbon atom in organic compounds, how to identify the different functional groups in organic compounds, and so on. So, all those were some introductory ideas. And then we started with the IUPAC system of naming organic compounds. Remember, IUPAC system of naming is a systematic method of naming organic compounds using certain rules and conventions. And that's what we checked out last class. Okay. Hope all of you have gone through those rules in your NCERT textbook and you have come prepared for the class. Okay. So last class we had stopped at naming compounds with multiple functional groups. You call them polyfunctional compounds. And in that I told you, when there are more than one functional groups, ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ functional group ಇದ್ರೆ, you will only consider one functional group as the main functional group. Okay, only one functional group will be considered as the main functional group. Rest of the functional groups will be treated as substituents. ಅದನ್ನ substituents ಅಂತ treat ಮಾಡಬೇಕು. Okay, then the question is how to decide which functional group is of main priority or top priority. For that, IUPAC has given out a priority sequence for functional groups. ಒಂದು priority order ಇದೆ. ಆ ಆರ್ಡರ್ ಅಲ್ಲಿ ಯಾವ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಫಸ್ಟ್ ಬರುತ್ತೋ ಅದನ್ನ ಮೇನ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಆ ಆರ್ಡರ್ ಅಲ್ಲಿ ಕೆಳಗಡೆ ಇರೋ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ಸ್ ಎಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. Okay, we also solved an example last class, if you remember. This was the example and most of you gave the correct answer. ಇಲ್ಲಿ ನಿಮಗೆ ಎರಡು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಕಾಣಿಸ್ತಾ ಇದೆ. ಒಂದು ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್, ಇನ್ನೊಂದು ಆಲ್ಕೋಹಾಲ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್. ನೀವು ಪ್ರಯಾರಿಟಿ ಲಿಸ್ಟ್ ನೋಡಿದ್ರೆ ನಿಮಗೆ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಫಸ್ಟ್ ಬರುತ್ತೆ. ಅದಾದ್ಮೇಲೆ ಕೆಳಗಡೆ ಎಲ್ಲೋ OH ಗ್ರೂಪ್ ಇರುತ್ತೆ, which means carboxylic acid must be treated as the main functional group and OH group will become the substituent. If carboxylic acid is the main functional group, then it will get the usual suffix name. ನಾವೇನ್ functional groups ಗೆ suffix ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅದೇ suffix ನ ಇಲ್ಲೂ ಯೂಸ್ ಮಾಡಬೇಕು. But you have to be careful, ತುಂಬಾ ಕೇರ್ಫುಲ್ ಆಗಿರಿ ಇಲ್ಲಿ. If you are treating a functional group as a substituent, functional group ನ substituent ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಅದ್ರ ಸಫಿಕ್ಸ್ ನೇಮ್ ಯೂಸ್ ಮಾಡಬಾರ್ದು. ಅದಕ್ಕೆ ಸ್ಪೆಷಲ್ ಪ್ರಿಫಿಕ್ಸ್ ನೇಮ್ಸ್ ಇದೆ. ಫಾರ್ ಎವ್ರಿ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ದೇರ್ ಇಸ್ ಅ ಸಫಿಕ್ಸ್ ನೇಮ್, ದೇರ್ ಇಸ್ ಅ ಪ್ರಿಫಿಕ್ಸ್ ನೇಮ್. ಓಕೆ, ಯಾವಾಗ ಸಫಿಕ್ಸ್ ನೇಮ್ ಯೂಸ್ ಮಾಡಬೇಕು, ಯಾವಾಗ ಪ್ರಿಫಿಕ್ಸ್ ನೇಮ್ ಯೂಸ್ ಮಾಡಬೇಕು ಅಂತ ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕು. ವೆನ್ ಅ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಈಸ್ ಟ್ರೀಟೆಡ್ ಆಸ್ ದ ಮೇನ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್, then it is to be given the suffix name. But when the same functional group becomes a substituent or is treated as a substituent, it is given the prefix name. Hope things are clear. ಇಲ್ಲೂ ಹಾಗೆ ಮಾಡಿದ್ವಿ ನೋಡಿ. ಈ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಮೇನ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಆಯ್ತು, ಅದಕ್ಕೆ ಸಫಿಕ್ಸ್ ನೇಮ್ ಕೊಟ್ವಿ. ಏನದು? ಓಯಿಕ್ ಆಸಿಡ್. ಫಾರ್ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಸಫಿಕ್ಸ್ ನೇಮ್ ಇಸ್ ಓಯಿಕ್ ಆಸಿಡ್. ಬಟ್ OH group, though is a functional group, is not treated as a functional group here because there is another functional group of higher priority present in this compound. Therefore, what do? You give the prefix name for it. What is the prefix name for OH? You can see here, I've circled it. It is hydroxy. Let me highlight it again. See this? Hydroxy. And therefore, you call it hydroxy, 4-hydroxy pentanoic acid. You also number its position, 4-hydroxy pentanoic acid. That's all you should know. So, ಈ ತರ ಎಕ್ಸಾಂಪಲ್ಸ್ ಅಲ್ಲಿ ನೀವು ಆ ಪ್ರಯಾರಿಟಿ ಆರ್ಡರ್ ನ ನೆನ್ಪಿಟ್ಕೋಬೇಕು, ಮೆಮರೈಸ್ ಮಾಡಬೇಕು. ಓಕೆ, ರೈಟ್. ದಟ್ ವಾಸ್ ಅಬೌಟ್ ನೇಮಿಂಗ್ ಪಾಲಿಫಂಕ್ಷನಲ್ ಕಾಂಪೌಂಡ್ಸ್. ನೌ ಲೆಟ್ us go to the next category, last category, naming aromatic compounds. Aromatic compounds ಗೆ ಏನ್ ರೂಲ್ಸ್ ಇದೆ ಚೆಕ್ ಮಾಡೋಣ. Can anyone tell me which is the simplest of the aromatic compound? Aromatic compound ಅಂದ ತಕ್ಷಣ ನಮ್ಮ ಮನಸ್ಸಿಗೆ ಬರೋದೇನು? Can anyone send it in the chat section? Simplest organic compound, organic aromatic compound. aromatic compound ಅಂದ ತಕ್ಷಣ ನಮಗೆ ಫಸ್ಟ್ ಹೊಳೆಯೋದೇ ಈ ಹೆಸರು ಯಾವುದದು ಹೇಳಿ ನೋಡೋಣ. ಯು ಕ್ಯಾನ್ ಯೂಸ್ ದ ಚಾಟ್ ಸೆಕ್ಷನ್. Simplest aromatic compound. It's the first compound among the family of aromatic compounds. What would that be? You can respond in the chat section. Yes, benzene. Pratibha, correct. Benzene. Benzene is the simplest of the aromatic compound. Okay. Now let us see how is benzene named under IUPAC system. Remember, benzene is a common name. Okay. Let's see how benzene is named. Benzene is named as, look at this. Benzene is a cyclic compound, has 3 double bonds. If you number it, it will be 1, 2, 3, 4, 5, 6. If you name benzene using IUPAC rules, you'll get a long name like this. Cyclo, hexa, 1, 3, 5 triene anta. Okay, it's a cyclohexane ring with 3 double bonds at position 1, position 3, position 5. Triene. Tri is to indicate 3 double bonds, ene double bond. So cyclohexa 135 triene. But this is a very long name. Every time you name an aromatic compound, you can't keep always writing cyclohexa 135 triene. Hence, IUPAC has adopted benzene, the common name itself, as official IUPAC name. Benzene is now the official IUPAC name. Therefore, you can straight away use or directly use the word benzene. You don't have to write cyclohexa 1, 3, 5 triene every time. Okay. So this one thing you should remember. Then in any aromatic compound, you have 2 parts. The ring or the nucleus, the hexagon with the pi electron cloud is called the ring or the benzene nucleus, and whatever group is attached to it is called the side chain. Okay. So you should keep in mind both these parts while naming the organic compound. There are 2 parts, nucleus and side chain. Let us take up some examples, simple examples. We now know benzene itself is official IUPAC name. Okay, right. And all other compounds are named as derivatives of benzene. Let's check it out quickly. Okay. So when one hydrogen atom of benzene is replaced by another atom or group, one atom of hydrogen replaced by another atom or group of atoms, then you call it a mono-substituted derivative of benzene or monovalent substituted derivative. Mono-substituted. Mono means 1. You remove one hydrogen, replace it with another atom or a substituent group. That's what is called as mono-substituted benzene. Let's see how we name that. Yes. If you have 2 hydrogens removed, you call it di-substituted derivatives. 3 tri-substituted. More than 3 poly-substituted. Okay. These are the examples you can get. Let me give you one example of a mono-substituted derivative. Something like this. See. Let's say you have benzene ring to which chlorine atom is attached. How will you name it? You will name it as chlorobenzene. Chlorine atom is a substituent. Benzene is the adopted IUPAC name. So chlorobenzene. I'll give you one more example. Nitro group attached. Can anyone tell me what will you name this as? In the chat section. Type ಮಾಡಿ ನೋಡೋಣ. In the chat section. No. What do you call this particular compound as? Try ಮಾಡಿ name ಮಾಡೋದಕ್ಕೆ. See, first one I have named it chlorobenzene. Chlorine atom attached to benzene, chlorobenzene. Here, nitro group attached to benzene. Yes, Vaishali. You're right. It is nitrobenzene. Nitrobenzene is the correct answer. Yes, very good. Very good. Yes, Savitha. Correct. All of you are right. Nitrobenzene. Nitrobenzene. Okay. So I'll be asking questions like this. So feel free to send in your answer in the chat section. Okay. Right. One of you asked full form of IUPAC. Probably in your last class attend agilla ansutte. I told that to you. It is International Union for Pure and Applied Chemistry. Okay. Yes. This is if one substituent is there. What if there is more than one substituent? Check this. If there is more than one substituent or something like say two substituents, then you have to be careful in numbering. Number ಮಾಡಬೇಕಾದ್ರೆ ತುಂಬಾ ಹುಷಾರಾಗಿರಬೇಕು. See, first case, two substituents are present on adjacent carbon atoms. Okay, 1 and 2. You should number it as 1 and 2. Next example, the substituent is present one carbon atom away. One carbon atom ಬಿಟ್ಟು substituent ಇದೆ. So it is 1 and 3. Another case, it is right opposite, 1 and 4. Okay, now ನೀವು ಯೋಚನೆ ಮಾಡಬಹುದು 1 and 5 ಆಗಲ್ವಾ? 1 5. Check this out. If I write something like this, ಈ ತರ ನಾನು ಏನಾದರೂ ಬರೆದ್ರೆ ಅದು 1 5 ಅಲ್ಲ, it becomes 1 3, because now you should come in the anti-clockwise direction. 1 2 3. Okay, this is where many mistakes are made by many students. Okay, 1 2 3 4 5. So ಹಾಗಂತ ಇಲ್ಲಿ ಹ್ಯಾಲೋಜನ್ ಅಥವಾ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ ಇದ್ರೆ ಅದನ್ನ 5 ಅಂತ ನಂಬರ್ ಮಾಡಬಾರದು. You should come from the opposite direction, because you should give the lowest number to the substituents. Okay, you should follow the first least point of difference rule. So 1 ಆದ್ಮೇಲೆ 3 anti-clockwise direction ಇಂದ ಇರುತ್ತೆ. Okay, so there's nothing like 1 5. It is 1 2 1 3 1 4. 1 5 ಇರಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ, 1 6 ಕೂಡ ಸಾಧ್ಯ ಇಲ್ಲ. 1 6 ಅಂದ್ರೆ ಅದು 1 2 ನ ಆಗುತ್ತೆ. See, if I write it here, that also is 1 6. Sorry, 1 2, not 1 6. Okay, you should understand this. First least point of difference rule. Okay, right. So apart from that, in common system of naming, you might also come across terms like ortho, meta, para. So ortho is two substituent groups on adjacent carbon atoms. Meta, one carbon atom away. Para, right opposite. So 1 2 is ortho, 1 3 is meta, 1 4 is para. Yes, this is all you need to know with respect to naming aromatic compounds. Okay, so far we have learnt rules for naming straight chain alkanes 1, branched alkanes 2, alkanes and alkynes 3, compounds with one functional group 4, compounds with multiple functional groups 5, and aromatic compounds. We have now discussed rules for these many compounds. Let us now check out some multiple choice questions. ಇಷ್ಟೊತ್ತು ನಾವು ಕಲ್ತ್ಕೊಂಡಿರೋ ರೂಲ್ಸ್ ನ ಹೇಗೆ ಅಪ್ಲೈ ಮಾಡೋದು ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. Okay, through these examples one by one. Yes, as always, you see the question. There are 4 options. Think, analyze, and then type in which option. Question number type ಮಾಡಿ ಆಪ್ಷನ್ ಯಾವುದು ಅಂತ ಹೇಳಿ. Otherwise ಏನಾಗುತ್ತೆ, I would have gone to the next question. ನೀವು ಮತ್ತೆ ಆಪ್ಷನ್ ಬಿ ಅಥವಾ ಸಿ ಅಂತ ಹೇಳಿದ್ರೆ ನನಗೆ ಈ ಕ್ವಶನ್ ಹೇಳ್ತಿದಿರೋ ಅಥವಾ ಪ್ರೀವಿಯಸ್ ಕ್ವಶನ್ ಆಪ್ಷನ್ ಹೇಳಿದಿರೋ ಗೊತ್ತಾಗಲ್ಲ. ಸೊ ಪ್ಲೀಸ್ ಮೆನ್ಷನ್ ದ ಕ್ವಶನ್ ನಂಬರ್ ಅಂಡ್ ದೆನ್ ದ ಆಪ್ಷನ್ in the chat section when you are sending in the answers. Okay, carefully look at this compound and name it. Revise all the rules that we had discussed. Yes, and then name it. Yeah, and send in your answer in the chat section also. Try ಮಾಡಿ. Come on. Name of the compound under IUPAC system is. You know what is the first thing you should do? Identify the root word, main chain. And main chain must be the longest possible chain containing the multiple bond. Okay, which would that chain be? This one. Longest possible chain containing the multiple bond. See this part. So root word ಏನಾಗುತ್ತೆ ಇದರಲ್ಲಿ? Pent. There are 5 carbon atoms. 1 2 3 4 5. Pent. See in which option there is pent? All the 4 options has the root word pent. Okay, now the next job is to number the chain. This is where you have to be careful. While numbering the chain, you should first give preference to the multiple bond, then substituents. First preference for multiple bond, then substituents. Okay, so here you have numbering from the right side. 1, 2, 3, 4, 5. This is the correct way of numbering, because if you come from the opposite end, let's say you start numbering from this 1, 2, 3, 4, 5. Please observe, in the first case, carbon with double bond gets position 2. In the second case, carbon with double bond gets position 3. You have to follow the lowest locant rule. So this numbering scheme is correct. This numbering scheme is wrong. Okay, I'm getting a lot of answers. Good. Very good. Let me see. Okay. Aishwarya, Channamma, Kirti, Aparna, all of you are suggesting option C. Ellaru option C suggest ಮಾಡ್ತಿದ್ದೀರಾ. Renuka, yes. Preeti, Sushmita, all of you suggesting option C. Very good. Very good. Let me see. Let me see whether it's correct or not. Yes. Keep the same level of participation going. Okay. Yes. Sai Kumar, Rakshita, Sahana. Yes, all of you are suggesting C. Okay. Let us see. So, main chain now identify ಮಾಡಿದ್ವಿ ನಾವು ಇವಾಗ, right? And we have also identified the right way of numbering. So it must be the one I have put a tick mark 1, 2. ಹಾಗಿದ್ದಾಗ double bond position 2 ಆಗುತ್ತೆ. Therefore it must be a pent-2-ene. See, option A is pent-2-ene, option D is pent-2-ene, whereas option B and option C are pent-3-ene. You can rule it out straight away. You can ignore it. Okay, in entrance exams, it's also important that you narrow down on options. You eliminate other options and you narrow down on the correct option. Okay, so B and C tappu anta gottayitu namge, because it's pent-3-ene. Pent-3-ene sadhyane illa. It would violate lowest locant rule. Okay, now you have to decide between A and D. A ಮತ್ತು D ಮತ್ತೆ decide ಮಾಡಿದ್ರೆ ಆಯ್ತು. Okay, now look at this. What are the substituents present? Methyl groups 1, 2, 3. 3 methyl substituents are present. Look at their positions. Second position, methyl substituents would be present in position number 2, position number 4, and one more in the same position, 4. And since there are 3 methyl groups, you have to use the prefix tri. 3 methyl groups. You'll have to use the Greek prefix trimethyl. Now we get the complete name. Check it out. It is 2,4,4 trimethyl pent-2-ene. It is option A. Most of you said it's option C. I'll tell you why you would have gone wrong. Yaak tappu madirtira ಹೇಳ್ತೀನಿ. This is the correct option. Just a second. Yes, option A is the right option. The reason why many of you made mistake is you would have started numbering it from left to right, thinking that you should give the lowest sum to the substituents. Okay? No. First priority is the multiple bond or the functional group. Functional group takes the first priority. Numbering should be done keeping functional group in mind. That is multiple bond, not substituents. So please keep that in mind. That's the reason why I selected this question. Very important. Okay. Right. Are we done? Can we go to the next question? Yes. Question number 5. Yes. The IUPAC name of this compound is, it's a branched hydrocarbon, alkane. What will be the IUPAC name of this? Send in the chat response. Let me see. Okay, so please type the question number and then send the answer. Please type the question number and then send the answer. Looks complicated, but if you follow the rules meticulously rules nalla apply madidre easy agutte. Okay, Arjun Reddy says B. Okay, let me see. Good attempt. Please make attempt. See, don't worry about the answer being correct or wrong now. You are learning. Okay, it's very important that you make an attempt. ನೀವು ಅಟೆಂಪ್ಟೇ ಮಾಡಿದ್ರೆ ಹಾಗೆ ಕೂತ್ಕೊಂಡ್ರೆ you'll not get motivated enough to study, and you'll not be interested in understanding it further. Don't worry about the answer being wrong. Okay? If the answer is wrong, one good thing is you get a new thing to learn and study and understand, right? So don't worry about the outcome. Please participate. Yes. Bhuvaneshwari says C. Jambanna says B. Hussaini says D. Okay. So yellow options are B, C, D. Right. Let me see. Let me clarify this. But majority are going with B. Okay. We'll check it out. We'll check that out. Let's look at the structure and start naming it now. First aspect is to identify the longest chain. Longest chain first now identify madbeku. Which is the longest chain here? See. 1 second. Let me select the pen. Just a second. Yes. This must be the longest chain. See. Straight chain. Because even if you come or even if you take it as the longest chain, there are two chains of equal lengths. It's one and the same. Okay. Now, once you identify the longest chain, look at the root word. 1, 2, 3, 4, 5, 6, 7. Root word hept. Root word hept. Okay. And then let us look at the other substituents. These are all substituents. This is ethyl substituent. Ethyl substituent. And these are methyl substituents. ನೀವು ಅನ್ಕೋತಿರ್ಬೋದು ಇದೇನು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ, ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ, ಇದೇನು ಆರ್ಗ್ಯಾನಿಕ್ ಸ್ಟ್ರಕ್ಚರ್ ಅಂತ. ಓಕೆ, these structures are called bond line notations. This is a bond line notation. All of you must be familiar with this bond line notation. Okay, in bond line notations you don't show or you don't represent carbon atoms with the alphabet C. Carbon atom is represented by a point. Every point here, ಇಲ್ಲಿರೋ ಪ್ರತಿಯೊಂದು ಪಾಯಿಂಟ್ ಕೂಡ ಕಾರ್ಬನ್ ಆಟಮ್ ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಅಂಡ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಆರ್ ನಾಟ್ ಶೋನ್. ಇಟ್ಸ್ ಅಂಡರ್ಸ್ಟುಡ್. ದೇರ್ ಪ್ರೆಸೆನ್ಸ್ ಇಸ್ ಇಂಪ್ಲೈಡ್. ಅಂದ್ರೆ ಇಲ್ಲಿ ಕೊನೆಯಲ್ಲಿ ಒಂದು ಪಾಯಿಂಟ್ ಕಾಣಿಸ್ತಾ ಇದೆ ನೋಡಿ. ಐ ಆಮ್ ಹೈಲೈಟಿಂಗ್ ಇಟ್. ದಟ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಈಸ್ ಅಸ್ಯೂಮ್ ಟು ಹ್ಯಾವ್ 3 ಹೈಡ್ರೋಜನ್ಸ್, CH3. ಆ ಕಾರ್ಬನ್ ಆಟಮ್ ಕೊನೆಯಲ್ಲಿದೆ, ಅದು ಒಂದೇ ಬಾಂಡ್ ಫಾರ್ಮ್ ಮಾಡಿರೋದು. ಇನ್ನ 3 ಬಾಂಡ್ಸ್ ಯಾವ್ದಕ್ಕೆ ಇರುತ್ತೆ? ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇರುತ್ತೆ. ಸೊ ದಟ್ಸ್ ಹೌ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್ ಇಸ್ CH3. Now the one in the middle somewhere here, that carbon atom has 2 bonds, so it will have 2 more hydrogens. Now look at the one here. Now highlight ಮಾಡ್ತಾ ಇದೀನಿ ನೋಡಿ in red color. That carbon atom is involved in 3 bonds, so it will have 1 more hydrogen ಅಷ್ಟೇ. So this is what is called bond line notation. Very convenient method of writing organic structures. Very time saving. ಇಲ್ಲಾಂದ್ರೆ ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಇದನ್ನ ಕಂಪ್ಲೀಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಬರಿಬೇಕು ಅಂದ್ರೆ you have to write so many carbons, so many hydrogens. Okay, time consuming. So all of you should practice this bond line notation. Okay, yes. Root word is hept. Substituents are ethyl and methyl. Now comes the question of numbering. Where should I start numbering it from? Let's look at 2 options. Let us start numbering it from left to right. 1, 2, 3, 4, 5, 6, 7. So what are the numbers or locant substituents get? Look at this. The locants will that substituent will get will be 4, another 4, because 2 methyl groups are there on the same carbon atom, and then ethyl group on 5th carbon. 4, 4, 5 in one scheme of numbering. Let's check it out in the opposite direction. 1, 2, 3, 4, 5, 6, 7. From right to left, what are the locants? ನೋಡಿ ಇಲ್ಲಿ ethyl group 3rd position ಅಲ್ಲೇ ಇದೆ, so 3. Then methyl group at the 4th position. Then one more methyl group at the 4th position. Now you have to follow the first least point of difference rule. ಏನದು? ಎರಡು ನಂಬರಿಂಗ್ ಸ್ಕೀಮ್ ನ ಕಂಪೇರ್ ಮಾಡಿ. ಯಾವ ನಂಬರಿಂಗ್ ಪ್ಯಾಟರ್ನ್ ನಲ್ಲಿ ಫಸ್ಟ್ ನಿಮ್ಗೆ ಲೋಯೆಸ್ಟ್ ನಂಬರ್ ಬರುತ್ತೋ ಆ ನಂಬರಿಂಗ್ ಪ್ಯಾಟರ್ನ್ ನೀವು ಸೆಲೆಕ್ಟ್ ಮಾಡಬೇಕು. ಐ ರಿಪೀಟ್, when you compare both the numbering schemes, in whichever scheme you get the first point of difference, lowest first point of difference, then that is correct. Nodi illi, in one pattern you get 4, in the other numbering scheme you get 3. Between 4 and 3, which is lower? 3 is lower. Therefore this numbering scheme is correct. 3, 4, 4 is correct. That is from right to left. This numbering scheme is correct. This is wrong. Okay. So hence you would name this as, look at this, 3-ethyl. Third position there is ethyl, 3-ethyl. Okay. There is only one option with ethyl in the third position. Ready? No other option has ethyl in third position. That itself is enough for you to mark the answer and proceed. ಯಾಕೆಂದ್ರೆ ಬೇರೆ ಯಾವ ಆಪ್ಷನ್ ಅಲ್ಲೂ ethyl third position ಇಲ್ಲ. This is the only option where ethyl is in third position. So it is 3-ethyl, 4,4 dimethyl heptane. This is the correct answer. Very, very important. Okay. So hope all of you have understood this. So big takeaway from this question is practice what are called as bond line notations. Bond line notations practice madi. Okay. Good. Now let me proceed to question number 6. Let me see if there are any questions or queries in the chat section. Just give me a minute. Okay. Yeah, most of you suggested option B. Option B, yara suggest madidro avರೆಲ್ಲ correct. Very good. Very good. That's right. Yeah. Again, my request, please mention question number. Some of you are doing it. Question number haki options entry ಮಾಡ್ತಿದ್ದೀರಾ. I would request others also to do the same thing. Okay. Next question. Question number 6. Okay. This is also on naming. Now see, I have made it slightly more difficult. First, bari hydrocarbons ತಗೊಂಡ್ವಿ. ಈಗ functional groups ಬಂದಿದೆ. Careful ಆಗಿರಿ. Okay. Yes. Preeti has raised hand. Yes, Preeti, can you send in your question as a chat, please? Preeti, you have raised hand. If you have any doubt, type in your question as a chat. Okay, there is one query from, I'm not able to read the name here. Okay. One question from a student who asks, please tell me the condensed structure of that compound. Okay. See, condensed structure would be where you write the carbon and hydrogen atoms. So, for example, if for question number 5, previous question, let me go to the previous question. For this, if I have tried the condensed formula, heg bariyodu, something like this. See, CH3, CH2, CH2, CH, CH3, CH3. Sorry, not CHC. One second. Let me erase that hydrogen atom, additional hydrogen atom editor. Yeah, all hydrogen atom irala. One second. Yeah. C, CH, CH2, CH3, then CH2, CH3. See how time consuming it is? That's why bond line notations are so convenient. Okay. Yes. Now let's go to the next question. Question number 6. First job. First kelsa eno? Root word. How do you find out root word? Longest chain containing functional group and maximum number of substituents. Okay. So if you look at the longest chain here, it would be this. See, the one with the OH functional group. This will become the longest chain. Okay. Now let me rewrite it. 1, 2, 3, 4, 5 and OH. I am only writing the carbon skeleton. Okay. ನೀವು exam ಅಲ್ಲಿ ಕೂಡ structures na ಮತ್ತೆ ಬರೆದು time waste ಮಾಡಬಾರದು. See, all these are entrance exams. Time is very, very important. Okay. You don't have to present your solution to anybody. Correct. So structures na ಮತ್ತೆ ಬರೆದು time waste ಮಾಡಬಾರದು. I am writing it here because I have to explain things to you. ಆದ್ರಿಂದ ನಾನು ಮತ್ತೆ ಬರಿತಾ ಇದ್ದೀನಿ. ನೀವು ಆ ಕೊಟ್ಟಿರೋ ಕಾಂಪೌಂಡ್ ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲೇ ವರ್ಕೌಟ್ ಮಾಡಬೇಕು. ಓಕೆ. ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್ ದಿಸ್. ದ ಲೆಸ್ಸರ್ ಯು ರೈಟ್ ಇನ್ ಎಂಟ್ರೆನ್ಸ್ ಎಕ್ಸಾಮ್ಸ್, ಫಾಸ್ಟರ್ ಯು ಆರ್. ಅದು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಬೇಕು. ನೀವು ಜಾಸ್ತಿ ಬರೆಯೋದಕ್ಕೆ ಹೋದ್ರೆ ಸ್ಲೋ ಆಗ್ತೀರಾ ಅಂಡ್ ಟೈಮ್ ವೇಸ್ಟ್ ಆಗುತ್ತೆ. ಓಕೆ. ರೈಟ್. OH ಹಿಯರ್, chlorine here, CH3 and one more CH3 here. Yes. This becomes the longest chain. And how do you number it? Remember, you should number the chain from that end where you have the functional group. Carbon atom with the functional group should be given the lowest possible number. So this is the carbon atom with the functional group. So number it as 1. Then you have 2, 3, 4, 5. So a lot of responses coming in the chat section. Let me see. Okay, 6th question, option B is suggested. Some of you are suggesting C. Soumya suggests C. Savitha is suggesting B. Kirti suggests C. So maybe B and C are confusion is answer. Okay, we'll just check it out. We'll just check it out. Okay, right. So we have identified the longest chain. Root word is pent, and primary suffix is all. See, sorry, secondary suffix. Functional group contributes to secondary suffix, and that is all. And these are substituents: methyl substituent, chloro substituent. This is chloro. Okay, let's start from the root word first. It's pent. Pent is the root word. No double bonds, no triple bonds, all single bonds. So ane, pentane. And now you are adding the secondary suffix all. Remember, when you are adding secondary suffix which begins with a vowel O, then you should remove the terminal E. Pentane. Bardaga konel ಒಂದು E ಬರಿತಿರಲ್ಲ ಅದನ್ನ drop ಮಾಡಬೇಕು. Whenever your secondary suffix starts with a vowel. Please keep in mind that small rule, okay? Pentane. Now, what is its position? First carbon, 1 all. Pentane, 1 all. Aitu. Now record the substituents. What are the substituents? Methyl and chloro. Methyl and chloro. And while recording the substituents, you should list them in the alphabetical order. First comes chloro, then comes methyl. What is the position for chloro? 4th position. So write 4 chloro. Then methyl groups at the 2nd and 3rd position. So it is 2, 3 dimethyl pentane 1 all. 4 chloro, 2, 3 dimethyl pentane 1 all. Which option is correct therefore? Option C. All of you would marked option C, right. 4 chloro, 2, 3 dimethyl pentane 1 all. Very good. Let me highlight the answer. This is the correct answer. Yes. That was question number 6. Now let's go to question number 7. Yes. The correct IUPAC name of the following aromatic compound is. See, this is an aromatic compound. And we today we learned the rules for naming aromatic compounds. Okay. In Nodi, there is an aldehyde functional group. This is aldehyde functional group. By naming aromatic compounds, IUPAC has one more convenience. What is it? Some common names of the compounds are adopted as official IUPAC names. For example, this compound here, benzene ring with an aldehyde functional group is called benzaldehyde. Common name is benzaldehyde. Benzaldehyde. But that itself is official IUPAC name. Adopted IUPAC name. So, either ಎಷ್ಟೊಂದು aromatic compounds ಆಗಿರುತ್ತೆ. Okay. Their common names itself will be adopted as IUPAC names. So, all other compounds are named as derivatives of these compounds. So, we should therefore consider this as benzaldehyde attached to 2 substituents. This is nitro substituent, nitro, and this is methoxy. Methoxy. See, alkyl group, R group with oxygen is methoxy. Okay. Nitro group and methoxy group. Okay. Right. Student named Shivaraju, please turn off your video. Tumba data consume agutte nimge tondre agutte. So keep your video off. Student named Shivaraju. Okay, if you're listening, please keep your video turned off. Please turn off your video. Okay. Methoxy and nitro. Now numbering part comes in. How do you number it? The aldehyde functional group, carbon with aldehyde functional group gets the lowest number 1. Then you start numbering the other substituents. 2 for nitro, 3 and 4 for methoxy. So numbering is also done. Next is listing them. You all know substituents must be listed in alphabetical order. Alphabetical order list ಮಾಡಬೇಕು. So ಇಲ್ಲಿ ನಿಮಗೆ ನೈಟ್ರೋ ಇದೆ, ಮೆಥಾಕ್ಸಿ ಇದೆ. Which comes first in alphabetical order? M. So first name methoxy, then nitro. So it is 4-methoxy, 4-methoxy, 2-nitro-benzaldehyde. Option C. Let me see how many of you have given option C as the answer. Check marna. Very good. Kavita suggested option C. Anand option C. Okay, good, good. So most of you have given option C as the answer. Very good, very good. So that is the correct answer for this question. Just a second. I'll highlight the correct answer. 4-methoxy, 2-nitro-benzaldehyde. Yes. Question number 7, an aromatic compound. Okay, I think these are the examples under naming system. You know the example there. No. Question number 8. The correct decreasing order of preference of functional groups according to IUPAC nomenclature of polyfunctional compounds is. Idalli now select ಮಾಡಬೇಕು ಯಾವುದು correct order ಇದೆ ಅಂತ. Let me see who will give the correct answer now. Send in a chat responses. Send in a chat response. Okay, good. Okay, many of you are suggesting D as the answer. Okay. Okay. Many of us suggesting D and C as the answer, but I doubt that's the correct answer. Here, all of you getting it wrong. And then you a priority list na odilla anta aitu. Odbeku. See, in previous class alagide. Okay, Asha says A. I think she is the only one who has given the correct answer now. A is the correct answer. Okay. Yes. See, the idea of these classes is to, improve your performance. Alva? So, one Hindi class alagiddanna cover ಮಾಡಿ next class ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅದನ್ನ ಸ್ವಲ್ಪ ನೋಡ್ಕೊಂಡು ಬಂದಿರಬೇಕು. That is called comprehensive preparation, complete preparation. Okay, post class, pre class. ನೀವು class ಅಲ್ಲಿ attentive ಆಗಿದ್ದೀರಾ, you are giving good answers, all that is fine. But please ensure that you have a pre class preparation and post class preparation as well. Otherwise, you will not reap the benefits of these classes. Okay, so please study and come. It is option A. Carboxylic acid gets the highest priority, then comes sulfonic acid, then amide, then aldehyde. So let me mark the correct answer here. Just a second. I'll highlight the correct answer first. Yes, option A. That is question number 8. Next, question number 9. One question with multiple functional groups. Try to answer it. Multiple functional groups. Let me see. So please identify the functional groups correctly. Let me rewrite the structure. This also is bond line notation. Convenient ways of writing structures. Okay. Now have a look at this. OH is alcohol functional group. Alcohol functional group, and this is ketone functional group. Ketone functional group. Now between alcohol and ketone functional group, which comes first in priority? Ketone. Important point. Ketone. Higher priority. Higher priority. Therefore, this becomes the main functional group. Main functional group. Okay, whereas alcohol OH becomes the secondary functional group, which is treated as substituent. Okay, so number the chain such that the main functional group gets the lowest number. So ನೀವು right side ಇಂದ number ಮಾಡಬೇಕು. 1 2 3 4 5. See, keto gets the lowest number. If you come from the other end, 1 2 3 4, ketone group gets the 4th position. That would be wrong. So this would be correct. This would be wrong. Now we'll name it. Keto is in the 2nd position. Root word is 1 2 3 4 5. Pent. Root word is pent. Its ane all single bonds, and keto group is present on the second position. So pentan 2-one. It's pentan 2-one. And then you have OH group at the fourth position. Remember, we had discussed it in the beginning of the session today. For OH group, you are not supposed to use the word or the term all. Illi functional group alladu. You should not use suffix. You should use its prefix name, which is hydroxy. Hence, you would call it 4-hydroxy. 4-hydroxy pentane 2-one. Which option is correct? 4-hydroxy pentane 2-one. Option B. Option B is right. 1 second. Let me highlight it. Option B is correct. Good. That was question number 9. Good. Now let's see if there is one more question, or else we'll move on to the next concept. Yes. So that was questions on IUPAC nomenclature. So ನಾನು ನಿಮಗೊಂದು 7-8 ಎಕ್ಸಾಂಪಲ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ. ನೀವು ಇನ್ನು ಜಾಸ್ತಿ ಎಕ್ಸಾಂಪಲ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. And you have some very good examples in your NCERT textbook. So please do solve them. Class 11, first PUC NCERT textbook. Okay. Yes. Next concept is isomerism. See, isomerism is a phenomenon where you have two or more compounds having the same molecular formula, but they differ in their properties. They differ in properties, okay, physical or chemical. So isomerism refers to that phenomenon wherein you have many compounds with the same molecular formula, but they would yet have different properties. That's what is called as isomerism. Yes. Yes, different properties. Same molecular formula. Now, isomerism is of the following types. Yes, this is a brief classification scheme for isomerism. Isomers can be classified broadly as structural isomers and stereoisomers. Now, structural isomers are those isomers which have, look at this, same molecular formula. Molecular formula same irutte, but they differ in their structural formula. Differ in structural formula or structure. ಈ structural formula ಅಂದ್ರೆ ಏನು? It simply refers to the sequence of arrangement of atoms. ಯಾವ atom ಆದ್ಮೇಲೆ ಯಾವ್ದು ಲಿಂಕ್ ಆಗಿದೆ, that sequence is referred to as structure. Okay, ಆ sequence change ಆಗುತ್ತೆ. Molecular formula same ಇರುತ್ತೆ, but the sequence in which you have atoms written changes. That's what is called a structural isomer. Okay, and stereoisomers, these are compounds which have same molecular formula, same structural formula also, same structural formula, but differ in spatial orientation of atoms. Spatial orientation of atoms. You therefore call them stereoisomers. Stereo is a Greek term for space. Okay, but in this chapter we are going to only discuss structural isomers. In this chapter, stereo will be taken up in one of the next chapters. Okay, now under structural you have the following types: chain isomerism, position isomerism, functional isomerism, metamerism, tautomerism. Okay, let's have a look at this one by one very quickly. Yes, look at the first set of examples. Butane, isobutane. If you observe it carefully, you'll notice in butane carbon atoms are in a straight chain, but in isobutane same number of carbon atoms are arranged in different pattern. You have 3 carbon atoms forming a straight chain and 1 carbon atom is branched off. This is what you mean by change in structure, change in sequence of connectivity. Okay, so this type of structural isomerism, where the compounds differ in the very carbon skeletal framework, carbon atoms arrangementally difference ಇದೆ. Okay, you find a difference in the chain of carbon atoms. In first case it is straight chain, in the second case it's branched. You call them chain isomers. Yes, this phenomenon is called chain isomerism. Next variety. Look at this. Can anyone tell me what is the difference you see in all the structures given here? You can see three structures there. All the three structures have OH group as common. All the three structures have OH functional group as common. Can you tell me what is the difference? You can send in the chat response also. Okay. What is the difference? OH group is sorry, that's common to all the three structures. In what aspect do they differ? See, number of carbon atoms also same. You have 5 carbon atoms. Yes, yes, Soumya. Soumya is correct. Different position of OH group. If you can observe, see, in one example here, let me mark it. Yeah. See, first one you have 1, 2, 3 OH in third position. In the other case, you have 1, 2 OH in second position. In the third case, you have OH in the first position. So such isomers which differ in the position of the substituent of the functional group, you call them position isomers. That's the second type. Next, check out these examples. Ethanol, dimethyl ether. One is alcohol, one is ether, but both have the same formula, C2H6O. Nodi? Molecular formula same, but one is an alcohol with OH functional group and one is ether. So here the functional group itself is different. Functional group is you therefore call them functional isomers. You therefore call them functional isomers. Therefore, you consider alcohols and ethers to be functional isomers. Likewise, you have other functional isomers as well, like aldehydes and ketones, okay, acids and esters, carboxylic acids and esters, nitrile, isonitrile, nitrile and isonitrile. All these are functional isomers. Other examples of functional isomers. Okay, you should be in a position to recognize it. So these are the different varieties of structural isomerism. So we have discussed 3 now: chain isomerism, position isomerism, functional isomerism. You have 2 more to go. Yes. Look at this example. Again, both are ethers. In one case, the oxygen atom is having 2 carbon atoms on one side and 2 on the other side. Equal distribution of carbon atoms, 2 and 2. In the other example of the same molecular formula, observe Madi, molecular formula change aapta illa. But see what is changing. 3 here, 3 carbon atoms here, and only 1 here. This is 2 and 2 on either side. This is 3 and 1 on either side. This is called metamerism. Yes. When isomers differ in the number of carbon atoms on either side of the functional group, you call it metamerism. Easy to remember. Easy to remember. Okay. Good. Next. Yes, Sushmita, you have raised your hand. If there is any question, please send it in the chat section. Let me check out your chat section. Please type your question in the chat section. Yes, please. Thank you. Next. There was one more type mentioned called tautomerism. Tautomerism is not explicitly discussed in NCERT textbook, but it's better you know it. Okay. Tautomerism is a phenomenon of, one second. Yeah, proton transfer. So this is seen usually in ketones and aldehydes. CH3, C double bond O, CH3. This form exists in equilibrium with this form OH double bond CH2. New structures compare ಮಾಡಿದಾಗ ನಿಮಗೆ ತಿಳಿಯುತ್ತೆ. One hydrogen from CH3, this hydrogen from CH3 is migrated to oxygen atom. Therefore, it gets OH. And therefore, you end up getting a double bond here. Okay? Yes. So, this is called tautomerism. Tautomerism. Okay? One second. Just a second. I'll be back. Yes. So that was the correct answer, tautomerism. Can you all hear me, all of you? Let me go to the next slide. Yes, we have questions on isomerism now. Questions on isomerism. 1 second. Let's see. Okay. Yes. Good. Please respond via chat. Send in your questions if you have any in the chat section. Okay. Yes. Now again, we'll follow the same method. Type the question number. Send in your response. We'll then verify which is correct. What is the relation between 3-ethyl pentane and 3-methyl hexane? Let me highlight it. Yeah. 3-ethyl pentane and 3-methyl hexane. Yeah. I'm quickly getting some chat responses. Very good. Okay. Manjula says option C. Ganesh C. Bhuvaneshwari says C. Okay. All of you are suggesting C as the answer. Yelru functional isomers anta heltidira. I mean, are you suggesting the option just because your friend says the same option? Atra agbardu. Okay. Kirti says A. That's good. Kirti is right. Inyaro option A suggest madidru. Sushmita suggested option A. Soumya suggested option A. Correct. Aparna, correct. Yes. So see, let me write the structures. 3-ethyl pentane hege bariyodu. Observe this. Let me select a pen. Just a second. Yeah. Pentane. 1, 2, 3, 4, 5. See, I'm using bond line notation. Time saving. Then third position. 1, 2, 3 have ethyl. Then 3-methyl hexane. This is 3-ethyl pentane. 3-ethyl pentane. And this is 3-methyl hexane. 1, 2, 3, 4, 5, 6. 1, 2, 3. Third position methyl group. 3-methyl hexane. 3-methyl hexane. So here, in what aspect do they differ? They differ in the very arrangement of carbon atoms. The skeletal framework of this hydrocarbon. Okay. Carbon skeletal framework. So these are chain isomers. Chain isomerism is the correct term. Good. So question number 10, option is not C, it's A. 11th question again on isomerism. Which of the following is not an isomer of this alcohol? CH3, CH2, CH2, CH2OH. Remember, alcohols and ethers are functional isomers. Alcohols and ethers functional isomers. So where is ether option here? Option B is ether. See, this is an ether. Now don't jump to the conclusion. Al ether nodida takshana functional group anta decide ಮಾಡಬೇಡಿ. Carbon atoms verify ಮಾಡಿ, formula verify ಮಾಡಿ. Okay, how many carbon atoms in the reactant or in the question? 1, 2, 3, 4. 4 carbons. Let's see whether there are 4 carbon atoms in option B. 1, 2, repeat it twice. 4. Yes, this is a functional isomer. Option B is a functional isomer. But here, look at the question. What are you supposed to find out? Which is not an isomer. Yaud isomer alla anta ನೀವು ಕಂಡುಹಿಡಿಬೇಕು. That's what is important. Okay. So B is an isomer. Now let's take up A. Look at the functional group in A. It's a ketone. A ketone is never a functional isomer with alcohol. Ketones and alcohols can never be functional isomers until and unless they are unsaturated aldehydes or ketones. Unsaturated aldehydes or ketones can be functional isomers of alcohols, not otherwise. This is not unsaturated. So adrinda A must be the answer. Yes. The correct answer would be A. Let me highlight it. Just give me a second. Yes. Correct answer is A. Yes. It's not an isomer. Now look at compound, given compound in option C. Option C is also ether. Let me mark it. 1 second. Yeah. Option C is also ether. But this is a ketone. Option D is an alcohol. So, in what way D is related to the given compound? Position isomer. position isomer. Yes, good. That's how it is. Question number 11 on isomerism again. Question number 12, another question on isomerism, very important type. Okay. These are quite common in entrance exams nowadays. How many structural isomers? You have to find out the number of structural isomers possible for the compound with the formula C5H10. Looking at the formula, it appears as though it's an alkene, and it's also mentioned it's an alkene. So there will be a double bond. So ee tara questions na hege approach ಮಾಡಬೇಕು, ಹೇಗೆ ಆನ್ಸರ್ ಮಾಡಬೇಕು? Follow this methodology always. Okay, ಏನದು? Observe ಮಾಡಿ. Write 5 carbon atoms in a straight chain. 1, 2, 3, 4, 5. Straight chain of 5 carbon atoms is the first possibility. Then fix the double bond. You can fix the double bond in the first position. This is one compound. For the same carbon chain, I can keep it in the second position, becomes pentuene, second isomer. Now, I cannot place it in the third position. Illi double bond include ಮಾಡಿ ಒಂದು ಹೊಸ ಕಾಂಪೌಂಡ್ ಬಂದಿದೆ ಅಂತ ಅನ್ಕೋಬಾರದು. This is same as structure 1, sorry, structure 2. If this is structure 1, if this is structure 2, this is same as structure 2. Same as 2. That's it. So from straight chain, all options are exhausted. Now go for branching. First level of branching. Hege 1, 2, 3, 4. 4 in a straight chain, 1 branched. Now put double bonds here. I'll place a double bond here. This becomes structure 3. If I place a double bond here, ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ double bond enter ಮಾಡಿದ್ರೆ ಅದು ಹೊಸ ಸ್ಟ್ರಕ್ಚರ್ ಆಗಲ್ಲ. It is same as structure 3. Same as 3. So how to verify? ನಿಮ್ಗೆ ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ, ಇದು ಸೇಮ್ ಸ್ಟ್ರಕ್ಚರ್ ಅಥವಾ ಬೇರೆ ಸ್ಟ್ರಕ್ಚರ್ ಅಂತ ಡೌಟ್ ಇದ್ರೆ, how to verify it? Very simple. Name it. Name ಮಾಡಿದಾಗ ಒಂದೇ IUPAC name ಬಂದ್ರೆ, then it's the same thing you've written. Okay. Then the next example is this. Next possibility is this is structure 4. Let me see if I can add one more structure. Illi double bond baribodalva. See, I can keep a double bond here. This will be structure 5. See, we've got 5 structures now. Okay, so for this branching, this is the end. Okay, now think of a 3-2 branching. 3 carbon atoms in one chain and 2 carbon atoms as a branch. Yes, but illi double bond include madakagatta? Impossible, because if you try to write a double bond, then you'll be suggesting valency 5 for carbon, so you can't get an alkene out of it. So now it is structure 1, 2, 3, 4, 5. 5 structures correct. I'll highlight the answer. Let's observe. 5 structures is what is right. Yes. That was question number 12 on isomerism. Okay. Right. Yes. Now we are going on to the next very important part of the chapter, where we'll try to understand some basic aspects of organic reactions. ಇಲ್ಲಿವರೆಗೂ ನಾವು ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್ ಬಗ್ಗೆ ಕಲ್ತ್ಕೊಂಡ್ವಿ. ಸ್ಟ್ರಕ್ಚರ್ ಹೇಗಿರುತ್ತೆ, ಹೇಗೆ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬೇಕು, ಹೌ ಟು ನೇಮ್ ದೆಮ್, ಹೌ ಡು ಯು ಕ್ಲಾಸಿಫೈ ದೆಮ್, isomerism, all this part. Now we are coming to organic reactions. Okay, some basic aspects of organic reaction mechanism. Let's quickly go through it. First, yes, see, there are the following ways by which bonds can be broken in organic compounds. A covalent bond. If a bond is broken in such a way that the one of the participating atom takes away both the electrons, you call it heterolysis, and that results in ionic species. Look at this example. Nodi, B takes away both the electrons, becomes B minus. IB is B. Okay, becomes B minus. A loses electron, becomes A plus. So heterolysis gives ions, cations and anions. There is another type of bond breakage wherein both participating atoms take away 1 electron each. It's a uniform bond breakage, hence called homolysis. And look at the species you get. You get what are called as free radicals. Free radicals with an odd electron. So these are the 2 ways by which bonds are broken. Okay, next. Yeah, homolytic fission, heterolytic fission. Homolytic and heterolytic fission. Next. This is just an illustration of it. See, homolytic fission again. ನೋಡಿ ಯಾವ ತರ arrows ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. These are called fish hook arrows. You call them fish hook arrows. Okay, yes. A few more examples of that kind. Next. Yeah. So we now know how bonds can be broken in organic compounds during organic reactions. Next, you come across a set of species called intermediates, which are formed in one step and get consumed in the next step in a reaction. Okay. So some of the common intermediates are, check this out, carbocation. Carbocations are species with a positive charge on carbon atom. Then carbanions, anion, carb anion, species with negative charge on carbon atom. And free radicals, species with odd electron. Yes. Okay. Yeah. Then you have reagents. Apart from intermediates, you have reagents. Nucleophiles and electrophiles. You must be familiar with these terms. Nucleophiles. Nucleophilic. Philic means liking. So nucleophiles are nucleus loving. They are electron rich. Whereas on the other hand, electrophiles, electron liking. These are electron deficient by themselves. Okay. So electron rich species seeking electron deficient centers, nucleophiles. Electron deficient species seeking electron rich centers, electrophiles. Okay. Now electrophiles but the nucleophiles ಎರಡು ತರ ಇರುತ್ತೆ. Check out the examples here. Yes. See, these are some of the examples of electrophiles. Positive electrophiles and neutral electrophiles. All these are neutral and these are positive. And electrophiles ನೀವು ಯೋಚನೆ ಮಾಡ್ತಿರ್ಬೋದು, ನ್ಯೂಟ್ರಲ್ ಆಗಿರೋ ಸ್ಪೀಸೀಸ್ ಯಾಕೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬೇಕು ಅಂತ ಅನ್ಸುತ್ತೆ? Because it will have incomplete octet or central atom will be attached to multiple bonds. Say in case of carbon dioxide, central atom to multiple bonds. Central atom with multiple bond. Okay. Yes. So these are all electrophiles. Similarly, nucleophiles. These are all species which are nucleophiles. Okay. These are all anionic species, nucleophiles, negative nucleophiles. And these are neutral nucleophiles. See, anion nucleophile behave ಮಾಡೋದು ಅರ್ಥ ಇದೆ. You can understand it. But why will neutral species behave like nucleophiles? Because they would have atoms with one or more lone pairs. Atoms with one or more lone pairs will behave as nucleophiles. So that's about the classification of reagents as nucleophiles and electrophiles. Good. Next. Yeah. Now coming to electronic effects. Remember, in a compound there will be many atoms and atoms differ in their electronegativity. Electronegativity andre nimgeಲ್ಲ ಗೊತ್ತಿರಬೇಕು. It's the ability of an atom to pull electron density towards itself in a bond, like a tug of war. ನೀವು ಹಗ್ಗ ಜಗಾಟ ನೋಡಿದಿರಲ್ವಾ? Two group of people will be holding the rope and whichever group is stronger physically would pull the rope towards them and that group wins. Adhe tara, even in case of atoms, they will have different pulling power with respect to electron density. That is what is called electronegativity. So because atoms will have different electronegativities, they will have different pulling power and that results in polarization, charge separation. That is what is called electronic effect. Adana ನೀವು electronic effects ಅಂತ ಕರೀತೀರಾ. Okay. Charge separation in an organic compound resulting polarity is called electronic effect. And this charge separation may be due to one, difference in electronegativity of atoms, two, presence of a reagent. Reagent in the kuda it's sadhya ide. Okay. So on both, due to both reasons, you can have electronic effects. Now electronic effects are of the following types, one by one. Let me show it to you. Yes. You have permanent effects, or also called polarization effects. You have what is known as temporary effect called polarizability effect. Polarization effect, polarizability effect. Okay. And under permanent effects, you have three types: inductive, mesomeric, hyperconjugation. Inductive, mesomeric, or it's also called resonance. Mesomeric or resonance effect, hyperconjugation effect. Okay. Under temporary, you have inductomeric effect and electromeric effect. Inductomeric effect ಬಗ್ಗೆ ತಲೆ ಕೆಡಿಸ್ಕೋಬೇಡಿ, it's not there in the syllabus. It's only electromeric effect. Okay, right. Let us now check out the important features of each of these effects. Okay, one by one. First, inductive effect. Yes. Inductive effect basically refers to movement of or displacement of sigma electrons along a saturated carbon chain towards more electronegative atom. So look at this example here. Chlorine is more electronegative. ನಾನು ಆಗ್ಲೇ ಹೇಳಿದ ಹಾಗೆ electronegativity ಅಂದ್ರೇನು? Pulling power. So chlorine is more electronegative, pulls the sigma electron density towards itself, thereby creates electron density deficiency on the other carbon, and that creates electron deficiency on the neighboring carbon. Like that, that effect travels through the chain. Okay. So this displacement of sigma electrons in a saturated carbon chain is what you call inductive effect. Okay. Now here you can have inductive effect operating in two directions. See, like I told you, it's like whichever group is stronger in pulling electron density, that group will pull it towards itself. Okay. And accordingly, inductive effect will be of the following types. Let me also tell you the salient features of it. See, it's a permanent effect. Remember, it's operated only in sigma bonds, no pi bonds. And inductive effect involves partial displacement of electrons. Electrons will not get completely transferred. Complete transfer agalla. It's just partially displaced. Then, as the length of the chain increases, inductive effect decreases. Important point. Inductive effect is distance dependent. Inductive effect is distance dependent. Okay. Bhuvaneshwari, please turn off your video. Please turn off your video. Yes. Thank you. Okay. I was telling you, inductive effect is distance dependent. As you move away from the substituent, the effect decreases. So it exists only up to about 2 or 3 carbons as a maximum, not beyond that. This is inductive effect. And depending on the direction of movement of electrons, you have inductive effect into the following two types. Two types. Plus I effect, positive inductive effect, negative inductive effect. So these are all the groups which come under positive inductive effect. These are all the groups which come under negative inductive effect. Usually, how do we remember or how do you recognize a group as plus I or minus I? Very simple. Remember this. All anions and alkyl groups are plus I. Easy. Anions and alkyl groups are plus I. Okay. And if you know a group is plus I, then all the other groups which is not plus I will be minus I. Okay. All other groups which is not plus I will be minus I. Hydrogen is kept as a standard reference. Inductive effect of hydrogen atom is taken to be 0. Inductive effect of hydrogen atom 0. Okay. As a standard. Now, all groups which are negative or alkyl groups are plus I. Rest of them are minus I. Okay. Yes. Next. Just a second. There seems to be an internet issue. I'll just check it up and I'll be back again. Okay. 1 second. Yes, we're back. So inductive effect type 2, electronic effect. Okay, next, resonance. Resonance is another very, very important phenomenon about which you should all know. You all know resonance phenomenon is seen in molecules which can be represented by more than one Lewis structures. Usually one compound, one structure bariತೀವಿ. But there are certain molecules and ions which can be represented by more than one Lewis structures. See this? Best example that is quoted is benzene. Multiple structures can be written for benzene. I have just shown two. ನಾನು ಎರಡು ಸ್ಟ್ರಕ್ಚರ್ ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀನಿ, ಇಲ್ಲಿ ತೋರಿಸಿದ್ದೀನಿ. You can write many more structures for benzene. When you can write many structures for a molecule, the question that arises is which structure is the correct structure? That's where the phenomenon of resonance comes in. See, even for carbonate, CO3 2 minus, you can write multiple structures. Okay, then which structure is correct? Observe this. Yes, for some molecules and ions, you can represent them by more than one structures. You call them resonance structures. This is what is called resonance. And which is the correct structure? The correct structure is a hybrid of all the structures that can be written. The correct structure is somewhere in between the structures that are written. Okay, please remember, none of these structures are the actual structures. It is all the actual structure alla. What is the actual structure then? Something in between all the resonance structures you can write, and that is what is a resonance hybrid, and that's how it's represented like this for benzene. Resonance hybrid. ಎಲ್ಲರೂ ಒಂದು ವಿಷಯ ತಿಳ್ಕೋಬೇಕು. It is not possible to write the actual structure of a molecule which shows resonance. Then what is it that we have written there? It's an approximation. Okay, the actual structure is somewhere in between all the structures you can write. Now, how do you know that resonance concept exists, or how do we justify it, or what is the evidence for it? Look at this. Carbon-carbon single bond length 1.54 angstroms. Carbon-carbon double bond length 1.34 angstroms. Okay. In benzene, if this phenomenon of resonance were not to exist, resonance ಅನ್ನೋ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಅಥವಾ ಫಿನಾಮಿನನ್ ಇರಲಿಲ್ಲ ಅಂದಿದ್ರೆ, ನೋಡಿ, ನಮಗೆ ಎರಡು ತರದ ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ಬಾಂಡ್ ಲೆಂತ್ ಬರಬೇಕಿತ್ತು. ಒಂದು ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ಸಿಂಗಲ್ ಬಾಂಡ್ ಲೆಂತ್, ಇನ್ನೊಂದು ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ಡಬಲ್ ಬಾಂಡ್ ಲೆಂತ್ ಅಲ್ವಾ? But look at the carbon carbon bond length in benzene. All carbon carbon bond lengths are identical, and it is 1.39 angstroms. Very important point, dear students. Please understand this. All carbon carbon bond lengths in benzene are identical, and it is 1.39. Now, how do you explain this? You can explain this only when you consider this phenomenon of resonance, suggesting that all bonds are identical and the bond length is intermediate to that of a single bond. You know, single bond length 1.54, double bond length 1.34. Bond length in benzene is neither single bond nor double bond. It's somewhere in between. It's somewhere in between 1.39. So this is the evidence in favor of resonance phenomenon. Yes, good. Hope all of you followed this. Now, resonance phenomenon. One second. Yeah, resonance phenomenon results in separation of charges, and that is what you call resonance effect. Yes, ಅದನ್ನ ನೀವು resonance effect ಅಂತ ಕರೀತೀರಾ. One second. Yeah. So due to resonance, there will be charge separation, and this is what is called as a resonance effect. Just like in case of inductive effect, even resonance effect is of two types: plus R effect and minus R effect. Plus R effect anta irutte, minus R effect anta irutte. What is plus R? Easy. See, with respect to inductive or resonance, you should always remember, if the system gains electrons, then it is plus. If the system loses electrons, then it is minus. Okay, plus minus symbol ಯಾವಾಗ ಯೂಸ್ ಮಾಡ್ತೀವಿ? If the system gains electrons from the substituent, plus. If the system loses electrons to the substituent, minus. ನಾವಾಗಲೇ ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್ ಅಲ್ಲಿ ಕೂಡ ನೋಡಿದ್ವಿ. Chlorine atom, minus I effect, pulls electrons from the system. Okay, whereas alkyl group pushes electron density towards the saturated carbon chain. So based on that, you use the symbols plus and minus. Illu hagene. Okay, resonance, positive resonance andre eno? One second. Yeah, positive resonance or plus R effect means what? A substituent or a group of atoms will push electron density to the conjugated system. This is called a conjugated system. System of alternate double bonds, double and single bonds. Conjugated system. We consider it as the conjugated system. Okay. So if the system is gaining electrons, it's plus R. Illodi, OH group is a plus R group because lone pair, please observe, lone pair on oxygen is in conjugation with double bond. Conjugation andre present at alternate positions. Okay. Lone pair alternates with double bond, because of which you get a new pi bond formed here and oxygen gets a positive charge and these pi electrons move towards this carbon atom. Again, see, that can be drawn into the ring, pushing out these electrons to the next position. Likewise, the pi electron system travels around the ring. Because the benzene ring gains the electron density and the substituent is giving it, you call it plus R. Ashte, very simple. Minus R is opposite to that. Minus R is opposite to that. Okay? Yes. Now what is it? Here, substituent will withdraw electrons from the ring. So substituent will be electron withdrawing from the conjugated system. Hence minus R. System is losing it. Okay, check it out. Nitro group. Nitrogen will pull electron density from the ring, thereby creating electron deficiency on the ring, positive charge. Compare Madi, minus R ge, here it is negative charge. Everywhere, negative charge here. Here it will be positive charge. Indicating system is losing electron density. So minus R. Loss minus. Gain plus. Remember that way. This is all about resonance effect. Resonance and resonance effect. Hope you understood this. Okay. Next thing that you should know is, sir, yav group plus R, yav group minus R anta hege gottagutte? Iga plus I minus I ge now one list ಮಾಡ್ಕೊಂಡ್ವಿ. I told you all anions and alkyl groups plus I. Anything other than this will be minus I. Easy. Adhe tara illu one pattern ide. Okay. We will now learn how to identify a group to be plus R or minus R. What is the clue or what is the feature for a group to be plus R and for a group to be minus R? Very important. Check this. Yes. This slide tumba important. ನೀವು ನಿಮ್ಮ ಸೆಲ್ ಫೋನ್ ಅಲ್ಲಿ ನೀವು ಇದನ್ನ ನೋಡ್ತಾ ಇದ್ರೆ ಸ್ಕ್ರೀನ್ ಶಾಟ್ಸ್ ತಗೊಳ್ಳಿ. ಓಕೆ, ಯಾವ್ದಾದ್ರು ನಾವು ಇಂಪಾರ್ಟೆಂಟ್ ಆದಷ್ಟು ಬರ್ಕೊಳ್ಳಿ. ಇಫ್ ಯು ಆರ್ ಅನೇಬಲ್ ಟು ರೈಟ್ ಎವ್ರಿಥಿಂಗ್, ಟೇಕ್ ಸ್ಕ್ರೀನ್ ಶಾಟ್ಸ್, ದೆನ್ ಯು ಕ್ಯಾನ್ ಕಾಪಿ ಇಟ್ ಇನ್ ಯುವರ್ ನೋಟ್ಸ್. ಒಂದ್ಸತಿ ಅದನ್ನ ನೋಡ್ಕೊಂಡು ಮತ್ತೆ ಬರೆದ್ರೆ ರಿವಿಷನ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಟ್ರೈ ರೈಟಿಂಗ್ ಡೌನ್ ಥಿಂಗ್ಸ್ ವೆನ್ ಐ ಆಮ್ ಎಕ್ಸ್ಪ್ಲೇನಿಂಗ್ ಇಟ್. ಇಫ್ ಯು ಆರ್ ನಾಟ್ ಏಬಲ್ ಟು ಇಟ್, ಟೇಕ್ ಸ್ಕ್ರೀನ್ ಶಾಟ್ಸ್. ಐ ಆಮ್ ಶೂರ್ ಆಲ್ ಆಫ್ ಯು ನೋ ಟು ಟೇಕ್ ಸ್ಕ್ರೀನ್ ಶಾಟ್. ಲ್ಯಾಪ್ಟಾಪ್ ಅಲ್ಲಿ ಕೂಡ ಸ್ಕ್ರೀನ್ ಶಾಟ್ ತಗೋಬಹುದು, ಸೆಲ್ ಫೋನ್ ಅಲ್ಲಿ ಕೂಡ ಸ್ಕ್ರೀನ್ ಶಾಟ್ ತಗೋಬಹುದು. ಓಕೆ, ಎಸ್, ದಿಸ್ ಇಸ್ ಅನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಲಿಸ್ಟ್. ಲಿಸ್ಟ್ ಆಫ್ ಗ್ರೂಪ್ಸ್ ವಿಚ್ ಆರ್ ಪ್ಲಸ್ ಆರ್, ಲಿಸ್ಟ್ ಆಫ್ ಗ್ರೂಪ್ಸ್ ವಿಚ್ ಆರ್ ಮೈನಸ್ ಆರ್. ನೀವು ಯೋಚನೆ ಮಾಡ್ಬೋದು, ಸರ್ ಇಷ್ಟೊಂದು ನೆನ್ಪಿಟ್ಕೋಬೇಕಾ, ಇಷ್ಟೊಂದು ಮೆಮರೈಸ್ ಮಾಡ್ಬೇಕಾ? ಪ್ಲಸ್ ಆರ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ ಒಂದು 10 ಕಾಂಪೌಂಡ್ಸ್ ಇದೆ, ಮೈನಸ್ ಆರ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ ಒಂದು 10-12 ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ಸ್ ಇದೆ. ಇಷ್ಟೊಂದು ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದು ಹೇಗೆ? ನೋ, ಯು ಡೋಂಟ್ ಹ್ಯಾವ್ ಟು ಮೆಮರೈಸ್ ಇಟ್. ಮೆಮರೈಸ್ ಮಾಡ್ಬೇಕಾಗಿಲ್ಲ. ಸಿ, ದಟ್ಸ್ ಒನ್ ರಾಂಗ್ ಬಿಲೀಫ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಹ್ಯಾವ್. ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಅಂದ್ರೆ ಮೆಮರೈಸ್ ಮಾಡ್ಬೇಕು ಅಂತ. ನೋ, ದೇರ್ ಇಸ್ ಅ ಪ್ಯಾಟರ್ನ್. ಯು ಹ್ಯಾವ್ ಟು ಐಡೆಂಟಿಫೈ ದಟ್ ಪ್ಯಾಟರ್ನ್. You can reason things out. You can analyze it logically. So organic chemistry na memorize ಮಾಡುವಂತ ಸಬ್ಜೆಕ್ಟ್ ಅಲ್ಲ. 20% memory aspect ಇದೆ, but not the entire thing. Okay, so this gives you an indication as to how you should approach organic chemistry. ನೀವು ಮೆಮರೈಸ್ ಮಾಡಿದ್ರೆ ಯಾವತ್ತಾದ್ರೂ ಮರ್ತೋಗ್ಬೋದು, ಅಂಡ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಇದಲ್ಲದೆ ಇನ್ಯಾವುದಾದ್ರೂ ಒಂದು ಫಂಕ್ಷನ್ ಗ್ರೂಪ್ ಕೂಡ ಕೇಳಬಹುದು. ಇನ್ ದಟ್ ಕೇಸ್ ಲೆಟ್ us see what the pattern is. ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಇಲ್ಲಿ ಎಲ್ಲಾ ಪ್ಲಸ್ ಆರ್ ಗ್ರೂಪ್ಸ್ಗೂ ಒಂದು ಕಾಮನ್ ಫೀಚರ್ ಇದೆ. ಏನು? Please observe. Atom attached to the conjugated system. See, you know, this is the conjugated system. Let's say this is a system. Okay, atom attached to the system will have one or more lone pair. So a plus R group, how do we identify a plus R group? Very easy. Okay, a group which contains an atom. Groups with atom having one or more lone pair. Having one or more lone pair. Okay, directly attached to conjugated system. Directly attached to conjugated system. Such groups are all plus R. ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಪ್ಲಸ್ ಆರ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋ ಎಲ್ಲ ಆಟಮ್ಗೂ ಸಿ ದೀಸ್ ಆರ್ ಕನೆಕ್ಟಿಂಗ್ ಬಾಂಡ್ಸ್. ಅವೆಲ್ಲ ಕನೆಕ್ಟಿಂಗ್ ಬಾಂಡ್ಸ್. These connecting bonds are used to link to the main conjugated system. All those atoms which are directly attached to the conjugated system, if they have one or more lone pair, ನೋಡಿ ಎಲ್ಲಾ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಯಾವ ಆಟಮ್ ಕನೆಕ್ಟಿಂಗ್ ಬಾಂಡ್ ಇದೆ ಅದಕ್ಕೆಲ್ಲ ಲೋನ್ ಪೇರ್ ಇದೆ ನೋಡಿ. That makes it plus R ಅಷ್ಟೇ. Very easy. Then what is minus R? Look at this. These are the connecting bonds by which the groups are attached to the conjugated system. Okay. Now, the atom, look at these highlighted atoms. Now, highlight ಮಾಡ್ತಿರೋಂಥ atoms ನೋಡಿ. Carbon here in most cases, nitrogen also, sulfur also. Okay. All those atoms which are directly connected to the conjugated system, in turn, are connected to more electronegative atom through multiple bond. ಸ್ವಲ್ಪ ಕಷ್ಟ ಇದೆ, ಕೇರ್ಫುಲ್ ಆಗಿ ಕೇಳಿಸ್ಕೋಬೇಕು ಇದನ್ನ. An atom directly attached to the conjugated system, in turn, is also attached to more electronegative atom by multiple bond. One example ನೋಡಿ ಇಲ್ಲಿ, carboxylic acid. Carbon atom conjugated system ಗೆ attach ಆಗಿದೆ. At the same time, carbon atom is also attached to oxygen atom by a multiple bond. That's what is a minus R group. Minus R group. Groups with atom directly attached to conjugated system. Directly attached to conjugated system, in turn attached to electronegative atom through multiple bond. So this is what makes minus R. So ಈ ರೂಲ್ಸ್ ನೆನ್ಪಿಟ್ಕೊಂಡ್ರೆ ಯಾವುದೇ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಕೊಟ್ಟರು ನೀವು ಅದು ಪ್ಲಸ್ ಆರ್ ಅಥವಾ ಮೈನಸ್ ಆರ್ ಅಂತ ಡಿಸೈಡ್ ಮಾಡಬಹುದು. ಓಕೆ, ದಟ್ಸ್ ಈಸಿ, ರೈಟ್? That is all is resonance effect, dear students. So we have studied two effects now: inductive, resonance. Now comes the last permanent effect, which is hyperconjugation. Yes, hyperconjugation, also called no bond resonance. No bond resonance. It's also called Baker-Nathan effect. Baker-Nathan effect, or it's also called sigma bond resonance, because what is involved in resonance here is sigma bond. Sigma bond resonance. Yeah, very good. Okay. Now, what is this effect? Basically, it's very similar to resonance, but the difference is here carbon-hydrogen sigma bond present adjacent to a functional group like, let's say, a double bond or a positive charge will be involved in conjugation. Okay, that is what is called as hyperconjugation. See this? This is the carbon-carbon double bond. Carbon attached to it is called alpha carbon. And all hydrogens attached to alpha carbon is alpha hydrogen. ಇದು ನೀವು ಸೆಕೆಂಡ್ ಇಯರ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ತುಂಬಾ ಓದಿರ್ತೀರಲ್ವಾ. ಸಿ ಆಲ್ಡಿಹೈಡ್ಸ್ ಕೀಟೋನ್ಸ್ ಎಲ್ಲ ನೀವು ಈ ರಿಯಾಕ್ಷನ್ಸ್ ಕಲ್ತ್ಕೊಂಡಿರ್ತೀರಾ. ಕಾರ್ಬನ್ ಆಟಮ್ ಅಟ್ಯಾಚ್ ಟು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಇಸ್ ಆಲ್ಫಾ ಕಾರ್ಬನ್. ಇಲ್ಲಿ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಯಾವುದು? ಡಬಲ್ ಬಾಂಡ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಸ್ ದ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್. ಮಿಸ್ಟೇಕ್ಸ್ ಮೇಡ್, ಕಾಮನ್ ಮಿಸ್ಟೇಕ್ಸ್ ಮೇಡ್ ಬೈ ಸ್ಟೂಡೆಂಟ್ಸ್. ಕಾರ್ಬನ್ ಆಟಮ್ ಆಫ್ ದ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಅನ್ನೇ ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡೋದು ತಪ್ಪು, ರಾಂಗ್. It's not the carbon atom of the double bond, it's carbon atom attached to double bond, or carbon atom next to double bond is alpha carbon. And all hydrogens attached to it are alpha hydrogens. Okay. Now see, all these alpha hydrogens are involved in resonance or conjugation with the pi electron system. This is called hyperconjugation. Resonance which involves sigma electrons of the carbon hydrogen bond, not any carbon hydrogen bond. ಯಾವುದೋ ಮೂಲೆಯಲ್ಲಿರೋ ಕಾರ್ಬನ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಅಲ್ಲ, ಕಾರ್ಬನ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಆಲ್ಫಾ ಟು ದ ಡಬಲ್ ಬಾಂಡ್, ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ಓಕೆ. ನೌ ಹೌ ಮೆನಿ ಹೈಪರ್ ಕಾಂಜುಗೇಷನ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಯು ಥಿಂಕ್ ಯು ಕ್ಯಾನ್ ರೈಟ್? ಯು ಕ್ಯಾನ್ ರೈಟ್ ಆಸ್ ಮೆನಿ ಹೈಪರ್ ಕಾಂಜುಗೇಷನ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಆಸ್ ದೇರ್ ಆರ್ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ಸ್. ಎಷ್ಟು ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ಸ್ ಇದೆಯೋ ಅಷ್ಟು ಹೈಪರ್ ಕಾಂಜುಗೇಷನ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಡ್ರಾ ಮಾಡಬಹುದು. ಸೊ ನಂಬರ್ ಆಫ್ ಹೈಪರ್ ಕಾಂಜುಗೇಷನ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು number of alpha hydrogens plus 1, the very structure of the compound is hyperconjugation structure. Okay, just a second, I am not keeping a look at the watch. I don't know how many more minutes left for me. Okay, I think we're almost coming to the end of the session. Okay, so this is how you calculate the number of hyperconjugation structures. Then if you are thinking, sir, what is the use of knowing the number of hyperconjugation structures? ಯಾಕೆ ಅದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? If you know the number of hyperconjugation structures, you can get to know about the stability of the compound. Okay, greater the number of hyperconjugation structures, observe madi, greater the number of hyperconjugation structures, greater the stability. So let's say compound A, alkene A has 9 hyperconjugation structures. Some other alkene B has only 3 hyperconjugation structures. One alkene ge 9 hyperconjugation structures ಇದೆ, ಇನ್ನೊಂದು ಆಲ್ಕಿನ್ ಅಲ್ಲಿ 3 ಹೈಪರ್ ಕಾಂಜುಗೇಷನ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಇದೆ. ಯಾವ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ? The one with 9 hyperconjugation structures will be more stable than the one with 3 hyperconjugation structures. Yes, so hyperconjugation structures are very helpful in identifying the stability of an alkene. Okay, yes. Next, last effect, temporary effect called electromeric effect. Okay, we will end the session with this effect. Soundarya, request you to turn off your video. Request you to turn off your camera. Yes, thank you, Soundarya. What is electromeric effect? Electromeric effect is a temporary effect. Temporary effect. Now what happens here? See, as it is in the compound, there is no charge separation. Compoundal charge separation ಏನು ಇರಲ್ಲ. But the moment a reagent comes closer to it, that induces charge separation in the compound. That induces polarity in the compound. This is what is called temporary effect, and such an effect involving pi electrons, is called electromeric effect. Okay. Now, permanent effects ಅಲ್ಲಿ ಇದ್ದಾಗೇನೆ ಇಲ್ಲೂ ಕೂಡ ಪಾಸಿಟಿವ್ ನೆಗೆಟಿವ್ ಎಫೆಕ್ಟ್ಸ್ ಅಂತ ಇರುತ್ತೆ. ಪಾಸಿಟಿವ್ ಎಫೆಕ್ಟ್ ಅಂಡ್ ನೆಗೆಟಿವ್ ಎಫೆಕ್ಟ್. Positive electromeric effect, negative electromeric effect. Okay, what is positive electromeric effect? Positive electromeric effect involves movement of electron density away from the reagent. Sorry, positive involves towards the reagent. I'm sorry, see this, pi electron density is moving towards the reagent, trying to catch that H plus. That is what is called positive. Negative is opposite. Pi electron density is moving away from the reagent. Nodi, cyanide ion is attacking this carbon. Cyanide ion is attacking this carbon atom, where pi electron density is moving away from it. That is what is negative. So one difference ನೀವು ನೋಟ್ ಮಾಡಬೇಕಾಗಿರೋದು ಇಲ್ಲಿ, permanent effects ಗೆ we define plus and minus with system as reference. Whereas electromeric effect, temporary effects, we describe plus and minus with reagent as reference. Okay, So this is all you have to understand. These are the brief points on electronic effects. Okay. Thank you, dear students. Next session, which is on Friday. My next session is on Friday. That's when I will be discussing MCQs on these electronic effects. Okay. Each chapter mugyatte. First chapter will be over. Okay. Thank you, all of you. Next class, we'll check out all these questions. Let me end the session now. Thank you. Thank you, all of you. Let me see if there are any chat queries, if I can just help you out. Yes, there have been requests for me to send these notes. I will be sending these notes as a PDF. Don't worry. ಎಲ್ಲ ನೋಟ್ಸ್ ನಿಮಗೆ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಇವತ್ತು ವರ್ಕ್ಶೀಟ್ ಬಂದಿದೆಯಲ್ವಾ, ಅದೇ ತರ ಈ ವರ್ಕ್ಶೀಟ್ ನಿಮಗೆ ಬರುತ್ತೆ. ಥ್ಯಾಂಕ್ ಯು ಆಲ್ ಆಫ್ ಯು. ಥ್ಯಾಂಕ್ ಯು ಆಲ್ ಆಫ್ ಯು.